Yesterday you learned about factorials and permutations. Who knew that an exclamation point is actually a mathematical symbol? Isn't that cool? So you came up with the formula for permutations yesterday. Either that or you just looked it up online because you couldn't figure it out or whatever, or you were lazy, whatever. So here's the formula for permutations. Permutations are groupings where the order matters. Very, very important. The order or the arrangement matters. Okay, the formula for permutation is this: a permutation having n total and r number of selections is n factorial over n minus r factorial. So, for example, well, let's write down first. N is the total, r is the selection. So if I have 10 items and I want to see how many ways I could select, okay, that's not actually a good example. Sorry, one sec. Okay, so instead of having 10 items, I have 10 people. They're running in a race. How many different ways can you give away the gold medal, the silver medal, and the bronze medal? So that's 3 options with the medals. So 3 selections. We're going with the first, second, and third runners. Is there a difference between first place and third place? Yeah. So the order matters because there's a real distinction between the 3 different options. Okay, gold medal, silver medal, bronze medal, definitely not the same. Okay, so then I would plug it into the formula 10 factorial over 10 minus 3 factorial. Ten factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 10 minus 3 is 7. So this should be 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, by the way, that was 7 factorial because that factorial drops down. Okay, 7 over 7 is 1, 1, 1, 1, 1, 1, 1. Okay, so 10 times 9 times 8 times 1 times 1 times 1 times 1, blah, 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 blah. Okay, 10 times 9 times 8 is 720. There are 720 different ways we could award gold, silver, and bronze medals to 10 runners in a race. All right. But how many of you want to write it out? Well, there's a beautiful thing called a calculator, and there's a reason why we use it, because it makes our lives easier. So if I wanted to do 10 permutation 3, I can actually use a calculator for it. But we'll get back to that later. Looking at today's classwork, 5 members of the Spirit Club have volunteered for the club governing board. These members are, that's Al, sorry. Al, Barbara, Carl, Dale, and Ernie. The club members will select 3 of the 5 as board members for the next year. One way to do this would be to elect a governing committee of 3 in which all members would have the same title. So they'd be like all the same level. There's no distinction between their jobs per se. Or you could elect a president, vice president, secretary. Very distinct difference here, okay? Yeah. How many different lineups of officers are possible? So if we're going to go the president, VP, secretary route, how many different ways could those officers be chosen? This means a president, vice president, and secretary are chosen. Thus, Al is president, Barbara is vice president, and Carl as secretary would be a different possibility from Al being president, Barbara as secretary, and Carl as vice president, okay? So you see the distinction, same group of people, Al, Barbara, Carl, but different jobs made it a completely different option. That makes another way of doing it is with Barbara being secretary rather than VP, okay? So same people, but the order does matter because there's a clear distinction between their jobs. So we're going to plug it in as a permutation. So what we need to do first is figure out what's my total and what's my selection. I have Al, Barbara, Carl, Dale, Ernie. 5 people. How many officers? President, VP, and secretary. 3. So I'm going to plug it in as 5P3. And I know I told you I was going to show you on the calculator later. Later is now. It's time to learn how do I plug in 5 permutation 3 into a calculator without having to do all the steps of the factorials. Well, I put a 5. And then I'm going to go to PRB, standing for probability. PRB, and look, I have permutation, combination, and factorial. So I'm going to press enter because it has permutation highlighted, and that's what I want. NPR 3. Enter. 60 different ways. Wow, so easy. So how many ways, how many different lineups of officers? 60 lineups. How many different 3-member committees are possible? In this case, it's a good idea to make a list of all the possibilities, which are combinations. Okay, so 3-member committees, if Al, Barbara, and Carl are on a committee, then Barbara, Al, Carl is not a different committee, okay? There's only one way to have those 3 people together. It's just them on a committee because there's no distinction between the jobs on the committee. If you're on the committee, you're on the committee. You're the same as other people that are on the committee, okay? So, they did Al, Barbara, Carl, Dale, Ernie, A, B, C, D, E. To make it nice and easy for us to complete these possible combinations, we're going to write them out. How many different 3-member committees are possible? We could have Al, Barbara, Carl, Al, Carl, Dale. Okay. The order that I've put this in is not the order that I'd like to do it in. I like to organize it specifically. Sorry about that. So what we're going to do is A, B, C, A, B, D, A, B, E. Now going to A, C. A, C, D, A, C, E. Now going to A, D, A, D, E. Any other possibilities? Of course. What about the committees that don't involve Al? Starting with B. B, C, D. B, C, E. B, D, E. And what about the committee that does not involve Al or Barbara? C, D, E. How many committees is that? Or possibilities? 10 different possible committees. All right, 10 possibilities. Felicia decides that she wants to volunteer as well. Blech, why? Okay. How many different possibilities for officers are possible now? Okay, we've just upped the total And they want us to do for officers. So is there a distinction? Does the order matter? Yes, this is a permutation. N is equal to 6 now. R is equal to 3. 6p3. We already learned how to do that. That's 120 possibilities. How many different governing committees are possible now? All right, let's try again. ABC, ABD, ABE, ABF, ACD, ACE, ACF. Sorry, just to follow my pattern. The ones without L. B, C, F. B, D, E. B, D, F. B, E, F. Okay, possibilities that do not involve Al or Barbara. C, D, E. C, D, F. C, E, F. And there's one more left. D, E, F. D, E, F. Whew, okay. How many options is that? "20 different options, 20 possibilities." Since there are more volunteers, they've decided to appoint another committee member. If they add a treasurer to the list of officers, how many different ways are there to select 4 officers possible? Awesome. We're going to finish this video after I teach my next class.